Hello and welcome. In order for the method of partial fractions to work, the top degree has to be less than the bottom degree. So what happens if that isn't the case? What happens if the top degree is greater than or equal to the bottom degree? Well, in that case, you would divide first. Divide first. So we're going to have to do some long division of polynomials. A favorite pastime, right? All right, let's get started. In example 4, we've got this integral of 2x cubed minus 4x squared minus x minus 3 all over x squared plus minus 2x minus 3. And you can notice that the top degree is 3, the bottom degree is 2, so top degree is definitely bigger than or equal to the bottom degree. So when you see that, the first step you're going to take is divide. That's actually going to be a helpful step because that's going to break down this rational function into some smaller pieces already. So let's write the long division for that. We've got 2x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3. Now if you remember how to do this long division, first you look at the leading terms, so that here we have 2x cubed divided by x squared, and then we write our answer up here. So that's going to be 2x. Then you take that 2x and multiply it by the divisor, which is this polynomial out here to the left, and write your answer underneath. And what we want to do is we want to line up the x to the third terms so that they get their own column, line up the x squared terms that they get their own column, and the x terms and the constant terms, so that the like terms are in their own columns. That way when you're combining them together, you don't make as many mistakes. So here we have 2x times x squared, which is 2x cubed, minus 4x minus 6x squared, so minus 6x. We'll go ahead and subtract down. So here notice that the 2x cubed minus 2x cubed is 0. The negative 4x squared minus negative 4x squared is 0. And then negative x minus negative 6x is like negative x plus 6x, which is 5x. Then we'll bring down the negative 3. And you know when to stop doing the long division when the degree you have here, which here in the case of 5x minus 3 has a degree of 1, is less than the degree of the divisor, which has degree 2. So we know that we can stop the long division here. So then to write up the answer to the long division, we write 2x plus 5x minus 3 over x squared minus 2x minus 3. So it's, in other words, the quotient plus the remainder over the divisor. So that's what we're going to do as a first step. We're going to write out that 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3 is equal to 2x plus 5x minus 3 over x squared minus 2x minus 3. Make that square a little bit better. Okay, so now what we're going to do is notice that the remainder fraction has the top degree less than the bottom degree. That's always going to happen because that's always where you stop the long division, is when the remainder has a degree that's less than the divisor. So you always end up with a fraction that's ready for partial fraction decomposition. So let's go ahead and apply partial fraction, the method of partial fractions on this smaller fraction here now. We're going to take that fraction and break it down. Go ahead and use a different color. So we're going to take this fraction, 5x minus 3 over x squared minus 2x minus 3, and break it down. And the first step in breaking it down will be to factor the denominator. So here we're going to get x minus 3 and then x plus 1. Now, we said that with linear factors, each linear factor gets its own fraction. So this is going to break down as a over x minus 3 plus b over x plus 1. Now, one common question is, well, what happened if you switch around the x plus 1 and the x minus 3? And that's okay. You would just get a over x plus 1 plus b over x minus 3. And then your a's and b's would be switched around, but when you solve them, they'll also be switched around. So when you plug the numbers back in, everything will work itself out. You'll still get the same result. So let me scroll down a little bit. And we'll take the step where we multiply both sides by, so the left side here by the right side here, by the LCD. Actually, we could use the factored version if you want to think about it that way. So we're going to multiply both sides there by, let me see here, x minus 3 times x plus 3 plus 1, excuse me. So we get 5x minus 3 equals a times x plus 1 plus b times x minus 3. And with linear factors, again, if you can plug in x values to make your life easier, that's going to be a good thing to do. So that's like the low-hanging fruit of these partial fraction equations, is if you can plug in an x value and immediately get one of the undetermined coefficients. And I see that x equals 3 will get rid of b and leave you with a. So again, I'm going to do some of this mentally. So 5 times 3 minus 3, that's going to be 12. Over here, we're going to get a times 3 plus 1, which is 4a. And when we plug in x equals 3 into the b times x minus 3, that becomes 0. So a equals 3. What's another x value we could plug in? X equals negative 1. X equals negative 1, we'll get rid of a. So we'll get negative 8 on the left side. The a term will be gone, and we'll have negative 4b. So we have b equals 2. So that's a pretty quick partial fraction decomposition. Now, what we've got to do is pull it together, so feed in the a and the b back into the expansion, which, remember, the expansion was for this fraction. It was the remainder fraction. So pulling it all together, we get... So let me do a different color here. Brown. There we go. So, I don't know why I keep picking brown. So the integral that we're looking at for this problem, the original integral, my son is sneezing in the background, is the integral of 2x plus 3 over x minus 3 plus 2 over x plus 1 dx. So remember that we still have this 2x plus, so we put that there, and then this remainder fraction broke down into a over x minus 3 plus b over x plus 1, where a is 3 and b is 2. So we had to feed those in there in order to write it out. Now we're just one step away. All we have to do is integrate each of those parts, and we get x squared plus 3 ln absolute x minus 3 plus 2 ln absolute x plus 1 plus c, and we're all set. Thank you for watching, and see you in the next part.